Hello Judge, we are Team Newbie. As students living in Malaysia, we are caught in a massive frustrating traffic jam almost every single day. We decide to take our own daily struggles, use them as our real-world scenario, and finally build a solution. The problem is that most traffic lights here rely on fixed timer or fragile road sensors. They are purely reactive. When a sudden traffic spike happens, the system doesn't know until the traffic jam has already formed, leading to massive delay and toxic emission. Our project is an AI-driven traffic prediction system. Instead of reacting to the traffic, we forecast it. By predicting congestion 15 to 60 minutes before it happens, we can proactively adjust green light to prevent the bottleneck entirely. This directly targets the SDG Goals 11, Sustainable Cities and Communities, by improving urban mobility, SDG Goals 13, Climate Action, by drastically reducing carbon dioxide and nitrogen oxide emission from idling vehicles.
Hi, my name is Eng Hui En. Now I'll show the geospatial part of our project using Google Earth Engine. This map focuses on our study area in Sri Kembangan, where traffic jams often happen at specific hotspots. First, we define a big area of interest, which represents the overall neighborhood impact. Then we define into smaller area. These are our jam hotspots, where congestion is the worst and emissions are expected to spike. This blue layer is our baseline scenario representing current traffic conditions. The road lines come from our results stored in BigQuery, including a geometry field so Earth Engine can draw the road segments directly on the map. Now I switch to the red layer. This is the AI improved scenario. It reflects the optimized traffic flow recommended by our AI pipeline. Notice the same road segments are shown, but the emissions value are lower under the AI scenario. Earth Engine also calculates the total emissions inside each area. Here is the console. We compare baseline versus AI inside the big UI and inside the jam hotspots. This is important because the biggest benefits should appear exactly where the jam is most severe. So in summary, Earth Engine helps us visualize where emissions concentrate, and it provides a clear before and after comparison. Our results show that reducing congestion in hotspot areas directly reduces emissions, supporting cleaner air and more sustainable urban transport.
Hi, so we built a dual simulation dashboard. So on the left side we have a fixed timing, which is the baseline, and the right side we have Vertex AI using dynamic timing. And on screen we have you're seeing both intersection, so north, south, east, west. So each direction has only 3 lanes, and that will be left turn only, straight only, and right turn only. So at the top you could see the current phase, the countdown timer, vehicles passed, average waiting time, and total queued vehicles. So over the baseline controller is simple and predictable. It cycles in a fixed order, clockwise, starting from north, east, south, west, and each phase has the same green time, like 15 seconds. This is safe and consistent, but it's not responsive. On the AI side, we connect to Vertex AI through a clock function. So at decision time, the AI receives live queue counts by lane and by direction, current phase context, simulation time. Then it recommends the next phase, the green duration, and a reason message that we display on the screen in the AI log. But here's a big upgrade we added based on a real traffic behavior. So the AI uses the same traffic logic as baseline first, and only overrides the decision if it produces a clearly better outcome. So we don't blindly trust AI, we treat AI as an optimizer, not a replacement. Alright, so let me proceed to a demo walkthrough, and right now I'll start the simulation. And then I'll inject traffic into one direction to create a heavy queue, so I'm injecting to the north. Great, so on the fixed timing side, you'll see it still waits for its turn. Yeah, And for the AI side, you'll see it respond by adjusting the duration. Yeah, so the duration and phase selection over here. So it's different. And importantly, it will not exceed the maximum green capacity, so it stays responsive without starving other sites. So in summary, Traffic Butter shows that AI can improve flow, but only when it's done with safe fallback rules and hard constraints that prevent extreme behavior. That's all. Thank you.